Good evening, ladies and gentlemen, boys and girls, or good morning, ladies and gentlemen, boys and girls, friends and neighbors. Today, what we're going to do is we're going to briefly look at Unit 5, Lesson 2, Inverse Functions, Activity Number 1. This should be Thursday's work, but I'm going to help you with it. So I'm going to quickly go through the first part of this video with you, of this activity with you, and let you do some on your own. So the first thing I want to do is find the steps outlined in your notes, find the inverse of this. I'm going to walk through this pretty quick because you should be able to do this. Step number 1, put y in for f of x. Bam, I did it. Next step is solve for x. Got down here, this little typo right here, this negative 1/5, subtract 2. Now I'm going to divide both sides by I'm going to multiply both sides by -5. Bam. That gives me -5. And then I added 3 to this as well. -5. And then I added that 3. I did 2 steps in one here. And so then I swapped the x's and y's, put the inverse into that, and so I got this. So you're going to be able to do that. One of the reasons why I did that is because I want to show you this right here. Another property of inverse functions is that they are a reflection. Remember your geometry. The graph of the inverse function is the reflection of the graph of the original about the line y equals x. So if I look at that line y equals x, and if I took that red line and flipped it over the y equals x, the red line would become the blue line. And keep in mind, the blue line is f inverse right here, and the red line is f of x. So we're going to talk about another activity about this reflection. If I took the blue and reflected it about this line y equals x, you're going to get the same. You're going to get the blue will become the red will become the blue. And then I found, what's the y-intercept here is going to be 0.0, 2.6, and that's going to be the x-intercept of the inverse. I found the x-intercept of f of x, which is 13, 0, and that's the y-intercept. 0, 13 is the y-intercept of the inverse. So I'm going to let you work that out. You can watch the video again if you want the answer, because you're going to need the answer. And then I'm going to let you work this problem out yourself. Be specific. I have a function, and you're going to tell me why this cannot be a one-to-one function. Okay? And this is the problem that I really want to concentrate on today, is this problem. Consider the quadratic function where the domain has been restricted. So I want to look at this function, but I'm only going to look at it on the domain x is greater than or equal to 1. And if I look at this quadratic, this is in vertex form that has this vertex of 1, 0. So this point right here is 1, 0. If I put 1 in, 1 minus 1 is 0, the output is 0. And so this is what this is this graph is a half of a parabola. And what's the range of that parabola? The range of that parabola, now let me write that in. I would like that range in yellow. The range of that parabola is y is greater than or equal to 0. So the domain is x is greater than or equal to 1, and the domain is y is greater than or equal to 0. And my first question about this, hey, why does this function have an inverse? Well, this function, a normal quadratic doesn't, because a normal quadratic decreases and increases. But this guy, since I'm looking at a restricted domain here, f of x is increasing on the restricted domain. So since f of x is restricted, increasing on the restricted domain, I'm going to tell you right now, home skillet, this guy exists. Okay? That guy does exist. And so now what I'm going to do is I'm going to help myself find this rule. All right? All right. Well, I'm going to find some values for f of x. And keep in mind, f of x is this function right here. I'm going to keep the f of x in blue. I want to keep, man. And I want some outputs for some specific inputs. If I put 1 in, I know it's 0. If I put 2 in, 2 minus 1 is 1, squared is 1. If I put 3 in, 3 minus 1 is 2, 2 squared is 4. 4 minus 1 is 3, 3 squared is 9. 16, 6 minus 1 is 5, squared is 25, 7 minus 1 is 36. Okay. So these are points that are on f of x. Okay, we know it exists. The inverse of this function exists. We know the inverse exists because f of x is increasing on this restricted domain. So I know, ladies and gentlemen, that this bad boy does exist. This guy does exist. Well, and the other thing I know here is that the range becomes the domain and the domain becomes the range. Well, then what is and what have I filled out here? Here I have filled out the domain. What's the domain of the inverse? The domain of the inverse is the range. Let me zoom out a little bit so we can see that. This domain, or this range, becomes this domain. Y is greater than 0. The domain here is going to be x is greater than 0. And this range, this particular range, is going to be the domain here. So the domain was greater than or equal to 1. And the range then is going to be y greater than or equal to 1. You swap the x's and y's. The range becomes the domain becomes the range. And now where did I get these points at? Where did these points come from? Well, what did I do? I just flipped these points. XY, YX, XY, YX. So the Y's become the X's, and the X's become the Y's. So I have a 0, 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, 6, 36, 7. All right. And so what I'd like to do here is what I want to do is graph the inverse on the grid above. So what am I going to do? Well, the first point I have is this 0.01. I'm going to graph that. I'm going to zoom out a little bit. Now I'm going to zoom out. So it's going to be 0, 1. I'll graph it in red. And then I have 1, 2. So I have 1, 2. I have 4, 3. And I'm going to sketch this graph. And that's the graph of and if I can see from what I was talking about before, this red graph is a reflection of the blue about this line y equals x. And they intersect somewhere, I think they intersect somewhere between 2 and 3. Hard to get the sketches perfect. And so could you guess a rule for the output of inverse? Could you guess a rule for that? Well, here's my function, y is equal to x minus 1 squared. This is f of x. Could you guess a rule for that? Well, it's going to have to be, I don't know. I'm going to let you talk about that. And well, I do know. And I do know how to do that, but I'm going to let you guess a rule. And I'm going to ask you tomorrow to see if anybody could actually develop the rule for f inverse, given that f of x is this, where x is greater than or equal to 1. A rule that would, for these inputs, have these outputs. And if I look at them, now let's look at the average rate of change. If I look at the average rate of change in the f, I know it's going to be positive, but look at this. Isn't this average rate of change going to be very low? Because it's almost, the slopes of the secants almost go to 0, and the slopes of the secants to the blue almost go to infinity. So the average rate of change of f is going to be large. It's going to be huge. And the average rate of change of f inverse is going to be super small. So as part of your assignment then is to do this. I want you to find the rule for the inverse of that, or find it or guess, see if you can't come up with that. And then I want you to finish, actually do this part right here. But then I want you to also do this problem right here, number 2. So that's going to end this video. It's a short 11, 12-minute video.